Okay, let's continue to the next question. Question 3 reads, a survey of the 30 students in Form 5 showed that some students use cameras or mobile phones to take photographs. They're giving us some information here and asking us to fill in the Venn diagram to show this information in terms of X, which is the number of students in both mobile phones, using both mobile phones and cameras. So the way that we do that is we're going to say that if 30 students exist in Form 5, then the universal set here is equal to 30. Now 20 students used mobile phones. So I'm going to go ahead and put 20 beside mobile phones, but keep it on the outside for right now. You'll see why. Because 4x students use only cameras. That means 4x will exist in the camera circle, but only in this section, not including this intersection. Because X students used both mobile phones and cameras. That means using both mobile phones and cameras, we label that intersection as X. It says 2 students used neither. But we also have this blank space to fill in, which we can find by saying 20 minus X, which gives us the number of students that use mobile phones alone. Okay. So write an expression in terms of X which represents the total number of students within the survey. The total number of students within the survey would include what's inside the camera circle plus what's inside the mobile phone circle plus this 2 on the outside. And it's an expression, which means no need to put an equal sign. That means we're gonna actually say 4x. Now we could say plus x and plus 20 minus x, but that's going to be redundant. So let's exclude this intersection and just say 4x plus 20 plus 2 gives us everyone inside this universal set. So 4x plus 22 is your answer for the expression. Now part 3 says determine the number of students who used only cameras. In order to do that, we're going to need to find an equal sign in here. 4x plus 22, we know, is everyone inside the universal set. So that should be equal to 30. So 4x plus 22 is equal to 30 means we can solve for 4x. 4x is simply 30 minus 22, which is 8. That means that x is equal to, you guessed it, 2. But guess what? You don't need to find what x is equal to. They're asking you for those who use only cameras. And those who used only cameras is 4x, which means we already have the answer to 4x, which is just 8. All right, smarter, not harder, guys. We're going to look at question or part B right now, which says, in the diagram below, which is not drawn to scale, we have AEC, and ADB, which are straight lines. Okay, great. They're both 90-degree triangles within the ADE and the ABC shapes. And they've given us the length of these lines. Now they want us to calculate the length of BC. All right, so the easy way to do this for 2 marks is to identify Pythagoras' theorem at work. We're going to say that, well, let's call this A, let's call this one B, and let's call this one C, because these little letters are opposite to the big vertices. So technically, we're going to have Pythagoras looking like A squared plus C squared is equal to B squared. I know you're usually accustomed to A squared plus B squared equals C squared, but the only thing that matters is that the hypotenuse squared is by itself on that side of the equation. Filling in the blanks gives us A squared plus, well, this side is 8 squared, and that's equal to 10 squared. What that means is A squared is equal to 100 minus whatever 8 squared was, which was 64. These are really convenient numbers because A squared must now be equal to 36, and you know the square root of 36. A itself is just 6. Awesome. So that is 6, in this case, meters. Remember units. Now explain why ABC and ADE are similar. The simple explanation for this is that they share the same makeup of angles. What I would say is that DE, the line DE, is parallel to BC. Therefore, we have what we call, these angles are now forming what we call F angles or corresponding angles. Corresponding angles. Now what this means is that all of the angles inside these two triangles are the same. And if all the angles are the same, then we have similar triangles. Okay, now for 3 marks, determine the length of DE. Determine the length of DE. First, we have to realize that DE is going to be similar to BC because these are similar triangles. What we need to first identify is by what scale factor are these triangles related. And the way that we do that is by comparing the ratios of side lengths. So we know that the big base is 8 meters, but do you know how long the small base is? Well, you can figure that out, because if this is 3.2, you can find this as 8 minus 3.2. So 8 minus 3 is 5, 5 minus 0.2 is 4.8. So that's 4.8 meters. Now here's what we're going to do. I would like you to set up this ratio. Big over small is going to give you the scale factor. That's just an easy way of remembering it. So the big length in this case is 8 meters divided by the small, which is 4.8 meters. That means that the ratio of sides here is going to simply be 8 divided by 4.8, which is 1.666, or 1 2/3. You could say 1.6 if you wanted. This is just a bit neater. So that means that the big triangle is the small length multiplied by 1 2/3. Or in other words, the big length divided by 1 2/3. So to find DE, we could say that DE multiplied by 1 2/3 is equal to 6 meters. What I'm saying is that this side scaled up by 1.66 would give us 6 meters. And I know that because 4.8 scaled up by 1.66 gave me 8 meters. So DE is going to simply be 6 divided by 1.666, or 1 2/3. If I put that into my calculator, we're going to say 6 divided by 1.666, and that's 3.6. DE is equal to 3.6 meters, and it makes sense that it should be smaller than that big length.